Today we're going to be talking about rational exponents, and I'm going to give you some rules that we're going to follow. The first one is a to the 1 over n is equal to the nth root of a. So in other words, if we have a fractional exponent, we're going to write it with a radical. A to the m over n is equal to the nth root of a to the m. Or you could also write it this other way. Either one of these is interchangeable. A to the m over n is equal to the nth root of a, all raised to the mth power. Now the thing is, our rules for exponents apply like they've always done. So, for instance, we learned rules for exponents when we were dealing with integer exponents. They still apply. So if we have 3 to the 1/4 times 3 to the 1/2, basically what you're doing is just adding your exponents together. So you have 3 to the 1/4 plus 1/2. Remember, you have to have a common denominator, so we could rewrite this. We can write 1/2 as 2/4. So 3 to the 1/2 plus 2/4 is going to give you 3 to the 3/4. Now, your direction said to write your answers with rational exponents, so we're going to leave it just like that. Okay, and I'm going to, there we go. Now let's say we have this next problem. We have x to the 7/8 divided by x to the 5/8. Remember, when you're dividing and the bases are the same, you subtract the exponents. So this is x to the 7/8 minus 5/8. Now that gives you x to the 2/8, and we can reduce 2/8, so you end up with x to the 1/4. Let's do this next one. We have y to the 4th, circle the last answer, y to the 4th raised to the 3/8 power. Well, we are multiplying our exponents together. Is an 8 here. So we have 4 times 3/8, and we can put a 1 under the 4. So we end up with y to the 12/8 power. And we can reduce 12/8 by dividing each of them by 4, so we have y to the 3/2. Okay, because this is what we multiply the exponents, remember, when everything is raised to a power, and you have an exponent on the outside of the parentheses. Now let's say we have x, y all together raised to the 4th power. You're going to have to raise each of those variables to the 4th power. So you're going to have x to the 1/4 and y to the 1/4. And there's your answer. Let's go on to the next page. Let's say we have x over y all raised to the 5/2 power. So we have to raise the numerator to the 5/2 power, so we have x to the 5/2, and the denominator to the 5/2 power, so we have y to the 5/2. Those are not like bases, so we cannot do anything else to simplify. We have x to the 2/3 y raised to the 0 power. Anything raised to the 0 power, remember, is always equal to 1, so our answer is just 1. Now, let's just review what I had mentioned earlier, writing rational exponents as radicals. If we have a to the 1 over n is equal to the nth root of a, okay, so that's our first rule that we're going to be thinking about. And then we have a to the m over n is equal to the nth root of a to the m. You can see where the m's and the n's come into play. If you wonder where this 1 would have gone, you don't have to write it in, but you can imagine putting it right here as an exponent on the a. Okay, now we want to write this expression in simplest radical form. So what we're going to do first, let's change it to rational exponents. So x to the sixth root of x to the second. Remember, your root, your index, turns into your denominator. So we're going to have x to the something over 6. Well, what's the exponent under the radical, which is the 2 in this case, goes into the numerator. So this is x to the 2/6. We can reduce that. Now, 2/6 becomes 1/3. X to the 1/3. Now it says write it as a radical. So we need to look back and say, okay, so I've got 1 over something for my exponent. Well, if I look at this formula that I'm circling here, this would be the same thing as taking and putting my denominator, that's my index, so that'd be a 3, and my x goes under the radical, and the exponent is the 1. Or you don't even have to have that exponent there of 1. You never have to leave an exponent of 1. So you can just write that as the cube root of x. It's just following this formula here. So that is all for today, and I thank you very much for joining me.